All right, let's review. The hope is that you tried this first. Solve this triangle. You know three sides. That's the law of cosine. Side, side, sides. That's first. To find a missing angle, pick an angle. So let's pick J. If I want to pick J, the measure of angle J, big, first of all, inverse cosine, then big fraction. And then for J, what side is opposite? And you square it. Then subtract the other side, subtract, the order doesn't matter. And then -2, and those last two sides again, and then type that in the calculator. This is what it would look like in the calculator. So you go blue button cosine, 2 parentheses, and then start typing. So 21 squared subtract 24 squared subtract 11 squared, divide, then another parentheses, then -2, not subtract, -2 times 24 times 11, close it twice, and then you get 61 degrees. That's J. I need to do it again for pick another letter, L. Again, inverse cosine. And if it's L, I'm going to start with 24, and then the order doesn't matter. And then -2 in those last two sides, and then type that in. Oops, too many. We got here. And then -2 times 11 times 21. And I got 92. I'll round that way. So L is 92. Now to find that last one, you would go 180, subtract, in this case, subtract 61, subtract 92. So 180, subtract 61, subtract 92. And that last angle is 27. Nice. All right, for here you just need to find the length A to C. I'll call that X. Recognize this is side angle side. So again, that's law of cosines. Big square root. So we're going to start with pick one side and square it, pick the other side, subtract 2 in those same two sides, and then cosine of that angle. And then you've used the law of cosines. So square root, all right, 8 squared plus 9 squared, subtract, not negative, subtract 2 times 8 times 9, and then cosine of 76, and I get 10.5. Good enough for me. It's in inches. 36, let's draw the angle DEF. Angle E is 47. D to E is 17, E to F is 16, and then find this angle right here. So in order to find that angle, I need to find a missing side first, so I need all three sides. Let's do that first. So the square root of 17 squared plus 16 squared minus 2 times 17 times 16 times the cosine of 47, and then type all of that in. So 17 squared plus 16 squared, subtract 2 times 17 times 16, and the cosine of 47. So that missing side is 13.2. Then, once I have that, then I can find the angle that I'm looking for. So to find angle F, inverse cosine, I now know all three sides. So for F, opposite is 17, then it's 16, then it's 13.2, and then -2, and then 16 and 13.2, and then type it in. And I get 70.4 or 5 as the missing angle. All right, number 37. A log ride at amusement park. It's now Tiana at Disneyland. It's one giant hill. The ride inclines with an angle of 33 degrees over a horizontal distance of 50. The angle of depression of the decline is 54 over a horizontal distance of 42. Find the height of the ride. Fun. So let's start writing what we know. So the ride inclines with an angle of 33 degrees over a horizontal distance of 50. The angle, so right there, so we have this, and then it goes down, and this is the angle of depression, which is outside the triangle. So if I want the angle, we'll talk about the angle inside in a moment, and then that has a horizontal distance of 42 to get down. So there's a picture, and I want to know what the height is. So what I'm going to do is I'm going to find one of these sides. So I'm going to pick a side like here. And in order to find that side that will be helpful, I'm going to use either SOHCAHTOA or just use law of sine. So I'm going to go, I need this angle up here. So I'm going to go 90, take away 33, that's 57. So I'm going to use that angle up there, 57. So I'm going to go sine 57, if I can write the number 57 over 50. And then sine 90 over x, and then solve for x. So I'm going to multiply and then divide. So I'm going to go 50 times sine 90 divided by sine 57. Get an answer. This is going to be a two-step process. So first step, so 50 sine 90 divided by sine 57. And I get 59.6. I'm going to call it 60. Now that I know that side, I can then solve for the height. Let's see. Just trying to think, because I can just solve for the height now, right? I could have went sine 33 for the height, and then sine 57 for 50. That's what I would do. And I'm not even sure if I needed what I did before. Well, I'm just going for it. So 50 sine 33 divided by sine 57 for the height. And I get a height of 32.5 feet. I'm trying to think, like, the angle in here is 36, and you'd have this angle over this. I don't know. I think that's it. And I don't think it's more complicated than that, but I feel like I could be missing something, but I'm going to go with that. 38. All right, two towers at a national park spot a forest fire. A tower A spots the fire at a bearing of north 38 degrees west. So we're going to go north and then 38 degrees west. And then it says tower B spots the fire. So if tower A is directly east of B. Here's B. So A is east of B, 729. And it says tower A, north. Same spot for the location. There's my fire right there. North, 48 degrees east. That's 48. And it says, find the distance from each tower to the fire. So that's X and that's Y, each distance to the fire. So I'm going to find that angle in there. So if I go 180, subtract 48, subtract let's try that again. this angle's 38. So this one in here, 90 take away 38 is 52. And then if I go here, that's 90 take away 48. That's 42. That goes in here. Now I can go 180, subtract 42, subtract 52. And that angle up there is 86. In fact, if I added these two angles, it would have gave me 86 too. So there'd be a different way to do it. So that's one way to do it. There's maybe a second way to also get 86 up in that corner. But we needed that, so sine 86 over 729. And I'm looking for each one. So let's start with 52 and then solve it. And then the second one would be the exact same setup. But instead of 52, the one opposite of y is 42. So sine 42 over y. And then solve them both. So to solve them both, again, I'm going to multiply and divide. So 729 times sine 52 divided by sine 86. That's 1. And that gives me 576, I'll round it. That's meters. Now for the second one here, I'll continue it over here. I'm going to cross again and divide. So I'm going to go 729 times sine 42 divided by sine 86. So I almost have the same thing here. The only thing I need to change is instead of 52, change that to a 42. And then the other distance is 489. And so there's the distances between the two. So you have y and x. Perfect. All right, turn the page. Find the area of this. How do I find the area of this triangle? So I have, I need to be able to find something here more than half. So this is isosceles. Do you see it 15, 15? So because it's isosceles, the same sides are always opposite of the same angle. So if this is 15, then same size exactly, that must be the same angle, which means I can go 180, subtract 39, subtract 39. I need to know that angle in between 15, 15. So 180, subtract 39, subtract 39. That's 102. Now, now I have what I need, because what I needed was side, angle, side. So now I have side, angle, side. The formula for side, angle, side is 1/2 side, side, sine of 102, and it's over. That's the formula to find area with a trig with side, angle, side. So 0.5 times 15 times 15, and then sine of 102, and I get 110. And that's millimeters squared. A triangular plaque has side lengths of 8, 13, and 15, and then find the area of this. So I just need to add 8, 13, and 15, and then divide by 2. So I'm going to add and divide by 2, 8 plus 13 plus 15. Remember, if I just go divide by 2, wrong answer. So press enter, then divide by 2, and you get the right answer. Then the formula is a big square root. It's 18. 18 take away 8. 18 take away 13. 18 take away 15. There is Heron's formula, or Hero's formula. Here we go. Second function there, square root 18. 18 take away 8. 18 take away 13. 18 take away 15. And I get an area of 52 inches squared. Graphing. So identify the amplitude and graph this. So the amplitude here in front is +1, and the period would be 2 pi divided by 4, which is pi over 2. I'm going to change this to pi over 2, change this to pi over 4, change this to negative pi over 4, negative pi over 2, and then I'm going to get started. So sine starts here at 0, so go 0, 0, 0. Because it's negative, it's going to go down to -1 and then up to +1, and that's the pattern all the way across. We have no amplitude for tangent. The period is 1 pi divided by 2/3 or times the reciprocal, so it's 3 pi over 2. So the second one is going to be 3 pi over 2, and then double 1/2, that's 3 pi at the end. Same thing here, -3 pi over 2 and -3 pi. Tangent starts in the middle, just like sine, and then in between are asymptotes. And then we go to the right and go up 2, and then go to the left and go down 2, and then you have 2 points to curve through. And then to the right, up 2, to the left, down 2, and then you can graph it. Done. Next one is secant, has no amplitude again. The period is 2 pi. Divided by, so we're going to go multiply times the reciprocal. 2 goes into 8, that's 3 pi over 4. So this is going to be 3 pi over 4. Half of that is half of 3/4. If I go 3 over 4 times a half, half of that is 3 pi over 8. So there you go. So this is 3 pi over 8, and this is 3 pi over 4. So you got 3. What's half of a fraction? So multiply by half, and you get 3 over 8. There it is. Secant starts with upper vertex. It's positive, so it starts at 1.5. And the next one will be low at -1.5. Next one will be up at +1.5. And then asymptotes in the middle. And then alternate. And the upper ones fold up and the lower ones fold down, and you have your graph. Again, no amplitude. The period is 2 pi divided by 2, or just pi. So this here, we can use it, or we can do what you're more comfortable. So make it pi, and pi over 2 is fine. Cosecant starts with an asymptote. So these three starts with 3 asymptotes, and you can do that on the left too. And then in between, I go to the first one, go to the right, go up to 3, it's up, and then I go to the next one, down to 3, and it's down, and there you go. Whoops, looks a little sloppy. And there's your graph. All right, here are some ones with phase shift. Again, you should be, doing it first, right? So we have cotangent with phase shift. The period would be pi divided by 1, which is pi. Phase shift positive pi divided by 1. Vertical shift is 3, which is our midline. So we're going to start there with 3, and then we'll change the scale to. So we'll change this to, it's right there. So the period is pi, so it's there. So the scale is fine. But I'm going to start there at pi and know that cotangent starts with a asymptote. So I'm going to then put in the asymptotes. In the middle of that is point of inflection, which is at the midline. Oopsie, right here. Sorry, that's part of the asymptote. Midline. And then go back to pi here. All of them are going to be the same, so it doesn't matter which one you start with. It's positive, so it goes to the left and then a half, and then to the right and then a half. And there you go. All right, one more graph to practice. Oh, this has a lot of good stuff to it. So I'm going to change this. I'm going to keep 2/3 x, but I'm going to change this to pi over 2 to make it easier to do the shift. So it's very similar, just change it to pi over 2. It does have an amplitude, which is at 2.5. That's in front. The period is 2 pi divided by that, which is the reciprocal. The 2's cross out, and that's 3 pi. We have a phase shift. It's negative pi over 2 times the reciprocal, 3 over 2. That's negative 3 pi over 4. Vertical shift's negative 1, which is our new midline. So we're going to start there at negative 1. Again, press pause and try it, right? Don't just copy. That's no learning. The phase shift. Well, let's change the scale. So 3 pi. Half of 3 pi is 3 pi divided by 2. So negative 3 pi divided by 2, and then negative 3 pi. To know where negative 3/4 is, half of 3 halves is, so if I went 3 halves times a half, like if I went half of it, you get 3 over 4. So negative 3/4 is halfway. So halfway on the midline, I count up 2.5. 1, 2, 2 point. There my graph starts. Then I go to the midline. Then I go down 2.5, back to the midline. To the midline, up 2.5, back to the midline, and then follow that pattern. Back to the midline. What did I do? I didn't go over enough. Here, this is the one. I didn't go over enough. Right here. Back to the midline. And then here, 1, 2, 2.5. All right, so now, what did I miss? I totally missed the pattern. So the pattern was good here, and then I went blech. So this one right here should have been in the middle. Then this one should have been at the bottom, and then this one should be back to the midline. So correct your mistakes, right? And ignore this part, so you can see it going through. All right, enough of that. Let's end with some inverse trig for this one. So what's inverse sine of root 2 over 2? What angle is that? That's positive pi over 4. What angle? It's a negative angle, and it's at pi over 3. What angle? This one's a positive one in quadrant number 2, so it's actually 5 pi over 6. You have to know your unit circle. These cross out and give me negative 2/7. These cross out, give me 3. This gives me 5 over 4. When it's an angle, I need to be careful, but this angle is in the correct location, so I can cross them out, and that's an answer. Same thing here, that's the correct location. It's in quadrant number 2, which is where it should be. This one is not in the correct one, so negative 3 pi over 2 takes me here, go a negative, it takes me up to the top, and so I need to write down the correct angle for that location for inverse trig, which would be just pi over 2. Here, 11 pi over 6 in our unit circle is right there, but I need to write it as a negative angle, so just be negative 1 pi over 6. 4 pi over 3 is right here. That's a negative value, so I need to write the same angle, but it's negative pi over 3. That would give me the same answer. Negative 5 pi over 4, man. So we're going here. So negative 5 pi over 4 gets me in quadrant number 2. And so in quadrant number 2, tangent's negative. So this is just going to be negative 1 pi over 4. That would give me the same answer, but in the correct location. Those are more challenging. These might be simpler. Inside, outside. So inside, what's the angle? Gives me root 3 over 2. That's pi over 6. What's the value of sine at pi over 6? And you have your answer. So keep working. Copying's not going to help. You need to practice and really work at your unit circle. Inverse tangent at 1. I know, lights just went off. All good. What angle? Gives me 1 for tangent. Remember, tangent's y over x. So at pi over 4, when you divide y divided by x, you get 1. What's the value of cosine at pi over 4? That's root 2 over 2. That's the x coordinate there. Here again, arc sine negative 1. So if I think of that, what angle is that? 0, negative 1. It's down at the bottom. And you can write that as negative pi over 2 or positive pi over 2. But most importantly, just take this point for tangent and realize that this answer is undefined. So arc sine -1 is at the bottom and tangent at the bottom. Using these, y over x is undefined. 62, the value of cosine at pi over 3 is the x coordinate at pi over 3. The inverse of that, where's the y coordinate, 1/2, is pi over 6. Sine at 2 pi is the y coordinate there, which is 0. Arc tangent at 0 is also equal to 0. What do we got here? Sine -3 pi over 4. All right, so if we think of our unit, it brings us here to quadrant number 3. So it's -√2 over 2. And then where is arc cosine -√2? We're looking at quadrant number 2 as a positive angle. So that's 3 pi over 4. 2 left. These are ones where I need to draw a triangle. So arc tangent's negative in quadrant number 4. So in quadrant number 4, I'm going to draw this, label it y over x, and then you'd use the Pythagorean theorem. When you solve this, I'm going to call it r. To solve for r, you would just square all this, add it, and square root this, and you get the answer 25. And then sine, using this, would be opposite over radius. So -24 over 25. Last one. So again, we're going to draw a triangle. Because it's positive, it's in quadrant number 1. Cosine is adjacent, 3√5, and then the radius, and I need to find the y coordinate. So I got 3√5 squared plus y squared equals 11 squared. So this is 9 times 5. That's where I got it. You see where I got 45? 3 squared, root 5 squared is 5. So 9 times 5. This is 121. So when I subtract 45, what do I get? I get 11, that's 6. That's 76, is that right? And then square root. I'm just going to leave it as a square root of 76. So the answer here is root 76 over the x value, which is 3√5, and just leave it at that. You could simplify it, but that's beautiful the way it is. Hey, I'm so proud of you for working, studying with me. I hope you tried it first. I hope you got support. Hope you don't give up. Till next time, Mr. G.